All right, everybody, welcome back to Ask a Dev. We're taking a look at for loops applied. This is part of our visual scripting crash course for creatives, and today we're going to be looking at nested for loops a little bit more deeply. Two different ways. First way, we're going to be going through just kind of a more traditional for each loop to find which character in our scene has an item. And then, as promised, we're going to be taking a look at something a little bit more traditional computer science using a bubble sort to sort the items in our array. So use the chapter links down below to skip ahead or do whatever it is you're interested in, or you can watch through and then skip out on the classic computer science stuff. But with that, let's hop in. Now, before we get into finding the character in our scene that has a specific item, let's just talk through it because it should make sense. For every character in our scene, if they have a backpack, what we want to do is we want to look at every item in the backpack. That is a nested for loop for every character, for every item in the backpack. And what we're going to do is we're just going to set up a quick little demo where we're going to try to find the character with the golden gun, for example. Okay, so to do that, let's hop in Unreal and knock that out using our for loops applied. We have our items base. So here's what we'll do. We're going to pretend these item bases are our characters. And what we're going to do is we're going to add a couple of variables, not dispatchers, variables. We're going to call one the item stash, and this is going to be a list of items that could be in their backpacks. And then the other one is going to be our inventory, for example, inventory, the actual things they're carrying. And in order to get this going, what we are going to do is we are going to put a bunch of things that could be in our inventory into our stash. So let's just add a bunch of stuff. Okay, so we have plasma, we have ammo, we have a shield, we have an axe. Let's do food, let's do Bitcoin, let's do the golden gun. That's the one we're looking for. We're trying to find the golden gun. We did plasma. Let's do unobtainium, silver, gold, and a hammer. Okay, so these are all the things that could be in our backpack. This first bit is just getting our character set up. Let's just do this. We'll add a begin play event here. And all we're going to do on begin play is we're going to fill each character's inventory based on random items from the stash. So we're not getting in the nested stuff. This is just the setup. So in order to do that, let's get a random int, in range. And let's say that the minimum number of items they might have would be 4. And the max would be, let's say 10. And then what we'll do is we'll do a for loop. And this is a special one. You can't just click on the for each. You have to type for loop. It'll pop up because what we want to use is we want to use the index. So basically what this is doing is this is saying for 0 to a number between 4 and 10, we'll add a random item to the inventory is what we're going to do. So in this particular case, now that we're looping through, we need to find a random item. So let's get the length of the stash and subtract 1. So this is the total possible items in the stash, and I want to get a random one from that. So let's get another random int in range. The range this time is going to be 0, and the length of our stash. So this is going to be a random index of the stash array, and then all we're going to do is we're going to get that item, and we are going to add that to our inventory. So here's our inventory, and let's add it. We're not going to worry about duplicates or anything like that. We'll just add it outright. So this is what we're adding. Here we go. Now let's make this a little bit more readable. Okay, here we go. So at this point, what we've done, this is just setup. This fills our array for our characters. And I'm actually going to move this up here because we're going to be moving off complete. All this does is it sets up our characters to have an inventory. And for kicks, let's just print that out. So when we're done filling, so this is going to be, we can put a comment around this, fill inventory. When we're done filling, let's just go ahead and print that. Sorry about the jump cuts today. I'm battling a cold, trying to edit out the coughs. So let's do here for each loop. And the array that we're going to be going over now is our now full inventory array. And what we'll do is we will print each item. So let's print the name of that. And we'll do 5 seconds just to make it easier to read, hot pink. And when we play, we should see all of our inventories. Now you can see gold, plasma, silver, golden guns, etc. What we want to do now that we have our setup is we want to find the character, in this case the item base, that has the golden gun. And to do that, we're going to use nested for loops. Remember, this is just the setup. This has probably happened when the game started or whatever. This is not really part of what we're doing. So here we go. Let's get all of the characters in our scene that are item based. So let's get all the actors of class. Get actors of class. In this case, we want the item bases. Item base. Now with these, not that was a single actor. I want to get all actors of class. Item base. Okay, so this is our first array. For each of the item bases, characters in our scene that we're looking at, we want to get all the inventory items. So let's get the inventory. And then for each item in the inventory, we want to see if it's a golden gun. So now this is a specific type of equals. Because we're using strings, you need to make sure that it's a string equals. And in this case, we're going to use golden gun. So if it's a golden gun, then let's go ahead and draw a debug cone. Not a circle. Draw debug cone. All right, and the origin is going to be at this actor's location. Hold on a second. The noodles are not behaving. All right, so get actor location, and then I'm also going to add about 50 units to it so that it floats a little bit above where the actor is. And that's the origin. The direction will be 1 on the z-axis. Basically, length, all this stuff is fine. Let's make it bright blue. Duration 1, thickness 1. Okay, so now that we have that, all we need to do, basically what's going to happen is right after we finish begin play, it's going to mark which ones have golden guns. So let's go ahead and take a look and see what we got. So in that case, the first two had golden guns. Now that was kind of fast, so let's just make it so that we can see. Let's do a duration of 5. Okay, so only one of our item bases has a golden gun in this case. In this particular instance, every time we start the game, it's going to change because it's randomly. So this is the only character with a golden gun. Now in this case, 3 people have, or 3 item bases have golden guns. So basically all we're doing is we're saying for every item base in the game, for every item in their backpack, is it a golden gun? If so, draw a cone. Now in your case, you may add a buff to the character. Who knows what you're going to do? You may mark it a special way. Could be an item interaction. But the overall point here is you have a for loop inside of a for loop. It should be pretty clear because you can actually just say it in just normal speech. And the way you're describing it, you'll realize you need to be using a nested for loop. So, real quick demo of when you might use a nested for loop. Now let's get into the more traditional computer sciencey stuff, and let's do a bubble sort. And a bubble sort is one of those things, it's like one of the first methods that you learn to sort arrays, and we've been doing a lot of sorting, trying to find the object that's closest to us and all those kinds of things. We're going to do this a little bit more out of context because we're just going to sort a list of numbers. And to do that, let's go first to an explanation of what we're doing and why it works. Okay, so the way a bubble sort works is it's called a bubble sort because the end result is it feels like the largest numbers are bubbling to the top. And it uses a nested array, a nested for loop. And basically the way you could think about them is the first for loop is the supervisor and the second for loop is the worker bee. So let's take a look at how this works. Here's our array of unsorted numbers. What we need to do is we need to check that each number is it larger than the next one? And if it is, we're going to swap the positions. And then when we're done, we know that after the first pass, the largest number has to be at the end. So how many passes do we need to make to check? Well, worst case scenario, we need to check the number of times for the number of elements we have in our array. So in that particular case, that means that we have to go through this 7 times. So 7 different times we need to go through the process of comparing the numbers and swapping them. So what that means is we have our supervisor array that's going to go through 7 times, and then we have our worker bee who's going to go through the array each time to do all of the swapping. So we have an array, a for loop inside of a for loop to do all the swapping. And what that looks like in practice is the first time through, we start with our first item that's at index 0, and we say, is the item in index 0 greater than the item in index 1? And if it is true, then we're going to swap them. So you can see here, now 21 swaps with 7. The second time through, our index is 1. We want to compare the item in index 1 with the item next to it, index 2. Is it bigger? Is 21 bigger than 5? Yes, it is. Swap it. Third time through, is the item in index 2 larger than the item in index 3? Why, yes, it is. We're going to swap them. So you can see here, we're going to go through each time. Is 21 bigger than 11? Yes, swap it. 21 bigger than 8? Yes, swap it. 21 bigger than 2? Yes, swap it. But we're not actually comparing 21 to 8. We are comparing the item in index 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4, then 4 to 5, 5 to 6, and then we're done. Now, that's the first time through. The supervisor has just put us through the first time. So now we know that the last item, item 21, the item in the last slot, item 6, the value of 21, is in its proper place. It has to be. Okay, so we do it again. Is the item in index 0 greater than the item in index 1? Is 7 greater than 5? Yes, it is. Swap them. Okay, great. Is the item in index 1 greater than the item in index 2? No, it's not. So it does not swap. Now, is the item in index 2 greater than the item in index 3? Is 15 greater than 11? Yes, it is. So it swaps them. And then so on. So it's going to go through and it's going to go 15 to 8. Yes, it is. Is 15 greater than 2? Yes, it is. Swap them, etc. And then finally we get to a point where you could keep going. You could say, is 15 greater than 21? We know it's not going to be. And this is going to be a point later that we'll talk about. And so it does not swap 15 with 21. And then we're now at a point where our last 2 digits or items are in the proper order. So you can kind of see we're basically going through and we're bubbling our way, we're bubbling to the top, the largest numbers. So we go through again, is 5 greater than, is the item in index 0 greater than 1? Is 5 greater than 7? No. 7 greater than 11? No. Is 11 greater than 8? Yes, so we swap. Is 11 greater than 2? Yes, it is, so we swap. And by the time we're done, our third array, our third element is in the proper order. This is how a bubble sort works. And the way it is implemented is in a nested for loop. So let's go do this in Unreal. And we are just going to do this on our third person character because it's just kind of an exercise. So what we will do is we will set, let's see here. Let's just do another timer by event. Set timer by event. And in this case, we'll set it to looping every 5 seconds. And the event that we are going to call, we'll add a custom one. Let's do this. Let's add an event, custom event, event bubble sort. And all this is going to do is going to call a function. So let's make a new function called bubble sort. And let's set up a couple things here. First, let's go back to our event graph and call bubble sort. Okay. So inside of our bubble sort, we do need a couple of things to work with to get started. So first, we do need let's first make a list or an array of random integers. So let's, in our local variables, I'm going to create a local number array. And we'll make this integers because that'll be sufficient, and we'll make it an array. And what we will do is let's make an array of, let's say, 20 numbers, for example. So each time we run this, what we'll do is we will, first we're going to go through, and we don't want to for each loop because I want to make a list of random integers we can work with. So we're going to go through, let's go through 20 times, 0 to 19, because that's 20. Remember, it starts at 0. And then in this loop body, what we'll do is we will add to this array. And what we are going to add to this array is a random integer in range, let's say 0 to 50. Okay, so this is just setup. This just creates a random array of integers, and just for fun, let's just print out what our local number array looks like when we start. So let's, for each of these, let's print it. We'll print the string, and we'll print the array element. Okay. This is going to be, and when we print it, let's print it for 5 seconds. And we'll start with red because it's unsorted. So when we start now, we should see our array print off to the left after 5 seconds. So here's our unsorted array. Great. Now let's do the bubble sorting. Okay. So off of this, remember what we said we needed. We needed a supervisor array. So, or a supervisor loop. So let's make another for loop. We got to break out of here. So let's go for loop. And I like to type for space loop to find this one because it's hidden at the bottom. All right, now here's where we need to start to pay attention, because this is where actually the bubble sorting is going to happen. Now, we're going to be sorting our local number array. The first thing we need is we need to set the indices that we're working with. We know we're starting at 0 because we're doing everything. So we start at 0, and we're going to go to the length of this -1. And the reason we're doing -1 is because, once again, the arrays are 0 based, and we don't want to go past the end. So the end is actually 19, not 20. All right, now what we are going to do, so this is our supervisor loop. inside, and this is going to ensure that we go through the process the number of times for the number of elements in the array. Then we're going to have our worker loop. And what our worker loop is going to do, it's also going to start at 0, and I'm going to copy this for now, because it's going to, in its first iteration that we're making, we're going to just go through every item. Okay? And what we're going to do is, there's a couple things we need to make a change to. Remember, as we go through, we're taking a look at our first item, our 0, and we're comparing it to the one next to it. So that's index plus 1, right? All right. So in order to do that, what we are going to do is we are going to go through and we're going to say, with our local number array, we're going to get the item at index 0 on the first try, and then we're going to get the item that is at the index plus 1. Now, this should send off a red flag for you. If it doesn't, don't worry. I'll explain why in a second, but let's add 1. And let's get that item. Okay, so this is the index. The item at index 0, this is the item at index 1. The second time through, it's the item at index 1, index 2, 2, 3, 3, 3, etc. However, if we get to 19 and we come in here and we're on 19, we get 19. What's 19 plus 1? 20. 20 is beyond the bounds of our array. So because we are looking at the next item, we want to make sure that we subtract off 2 for our worker bee array, because it's looking ahead into the future. We subtract off 1 because it's 0 based, and 1 more because we're looking one more into the future in the worker bee array. Okay, so we don't want to go beyond the bounds of our array. Okay, so then what we are going to do is we're just going to compare these. Is this item greater than the one next to it? If that is true, we are going to swap them. So if this works out to be true, then what we want to do is we want to swap these two items. The cool thing is Unreal gives us a thing called swap, so we can swap array elements, and the array elements that we are going to be swapping are going to be this one and this one. Okay. Make this a little bit easier to look at. And that's it. Now, there's a couple things that we're going to double check that this is working, of course. And then let's talk about a couple of things from an efficiency standpoint. But basically, so what happens is, for every item in our array, we are going to send a worker bee to look at it. And the worker bee is going to say, is the item an index 0 greater than 1? Is 1 greater than 2, 2 greater than 3? If that is true, it's going to swap them and it's going to keep working its way through. So theoretically, what should happen now if we print our array, and we can just copy this when we're done. Now that we're done, our local number array should be sorted. Let's print the exact same thing, except this time we'll print it green. So now when we start, after 5 seconds, it should print a list of red numbers and a list of green numbers. And you'll notice the red ones are out of order and the green ones are in order. 1, 2, 3, 111. And it's just going to repeat this. Every 5 seconds, it's going to update to change. And you can see it's basically generating a random array and then it's printing it out in order. Okay? Cool. So now, if we look at this, there are a couple of things that might potentially be worth considering. Basically, bubble sorts are generally considered, they can be one of the slower search algorithms, because if everything is perfectly out of order, it means you have to go through every single item to get it all in order. But the part of the problem is you don't actually know. So how can we make this bubble sort a little bit more efficient. So let's talk about these. And this is why I broke out a couple of these things. Number one, if you noticed, each time we went through this bubble sort setup, after each pass, we were guaranteed that the last couple of items are already in order. So the first time through, we're not guaranteed anything. Second time through, we're guaranteed that the last item is in the right place. The third time through, the last two items, the fourth time, etc. That number is the exact number of the index of our supervisor script. So the index of our supervisor for loop is 0 the first time through, 1 the second time through, 2 the third time, and so on. And so what we're saying is that if we don't really have to check the last supervisor index number of items. Now, when you only have 20 items, it doesn't matter. But if you have 10,000 items, you don't want to check the last 5,000 of them if you don't have to. So what we can do is we can make a quick little change here, and instead of just subtracting off 2, we can subtract off 2, and we can also subtract off the index of the supervisor. Okay, so -2, -0, -2, -1, etc. So if we just double check and make sure that that still works, that should basically just simply be skipping the last item in the index. So we still get our sorted list. That's great. Okay, that's cool. Now don't get confused by the blue 4 that's printing up there. It looks a lot like the green ones. But overall, the point is we've just made our loop a little bit more efficient by using our understanding of how this sort is working and ignoring the ones that have already been sorted. Now there's one other case that potentially can happen, and that is all of the items are already sorted. Maybe they weren't the worst case scenario. Maybe only half of them were out of order. Well, in that case, what can happen is let's say that your array was already sorted when you started and you had 10,000 items in it, you would still go through that array 10,000 times. So what we can do is we can do a test. And what we can test for is, did we actually swap something? Because if we didn't swap something in the worker bee for loop, then what ends up happening is we know everything's already in order and we don't have to keep going. So let's account for that. And what we're going to do is we're going to create a boolean swap found. We need to set this to be a boolean, and we're going to make it a single. And what we'll do is when we start, we'll set our swap found to be false, just to make sure. Okay. And then in our worker bee, if we come in here and we do a swap, we just want to set it to true. Okay. Now, when we finish our worker bee, what we want to check is, now we would check to see, did we find a swap? So if not, actually we're going to say not, if we did not find a swap, not equals, that's not what I want. I want a not boolean. Not boolean. If we did not find a swap, that means that these are already in order. And what we can do is we can break out of that, of all of it. We can just finish. So what we can do is we can replace this for loop with a break. So let's do that. For loop with a break. And it works almost exactly the same thing. Let's connect it all up without the break first. So we're just going to move all of our pins. I'm doing this by control dragging. Okay. And all we're going to do is, if we find this to be true, we're going to break. So let me just go ahead and do this. Now, the chances of all of our stuff being in order on the first pass is very small, but at least we've accounted for it now. This entire section here is our bubble sort. I'm going to comment it as such, bubble sort, so that it's all here. And theoretically, as long as we didn't make any mistakes, when we play, we should still see all the same stuff we saw before. We should see our red out of order list, and then we should see our sorted green list. Now remember this blue floor that shows up, that's not part of the sorting, but you can see everything is still sorting properly. And we've now accounted for some of the efficiencies, or some of the ways that we could potentially make a bubble sort more efficient. Now, as I was describing, because of the way the bubble sort works, because you're going through every single item every single time, it is considered one of the more inefficient sorts. If you're sorting really large data sets and things like that, generally people will use insort sorts, or there's a lot of different sorts, okay? But it's still really cool, as an example, from a traditional computer science and intro visual scripting thing, to understand how a nested for loop might work in the case of a bubble sort algorithm. As always, thanks for checking out the video. Thanks for checking out Ask a Dev. Thanks for being part of this community. All comments, feedback welcome. Throw it down in the comments down below. Don't forget, we're available on Discord and Patreon. You can find those links down in the comments and description below. You know how this stuff works. If you like what we're doing, help us out, spread the word, let people know we're here, let people know what we're all about. And hopefully we will see you in one of our upcoming live Unreal Engine demos sometime in the near future. Have a great one. See you all in the next training. Later.